I am John Henrik B. Orapa from the Bachelor of Secondary Education, major in Science. And welcome to Fluid Mechanics. So we are given a task to do a vlog documentation that will give examples of the types of fluid flow. So at this video, I'll be showing you some examples that exist here in our campus, the Baisukan High campus. So let's go. An example of steady flow is air conditioning system. That one. Let's consider we are in a closed room where the air conditioning system is maintaining a constant flow of air throughout the room. So right now, we are in our library. So the velocity and direction of the air remain constant over time, which is representing a steady flow. That is why air conditioning system is considered a steady flow since we are in a closed room. An example of non-steady flow is when I open the window, then close it again. But why? It is because when I open that window, then close it again in the same room at irregular intervals or at different time, I am causing sudden changes in airflow direction and velocity, which represent the non-steady flow. An example of a uniform flow is this fan. But why? It is because this fan blows air uniformly in one direction since this fan only faces downwards. It doesn't go in the other way or left or right side. It only faces downwards. So the airflow on this fan remain constant in both speed and direction throughout the room, which is in the library, representing a uniform flow. An example of a non-uniform flow is when I shake this bottle with the water inside of it at rest. But why? Initially, the water is at rest. But when I shake the bottle, the water starts moving in different direction with varying velocities. This variation in velocity and direction of flow represent a non-uniform flow. An example of a rotational flow is a ceiling fan. This one and this one. But why? It is because the air around it moves in a rotational manner as influenced by the spinning blades of it. These are the spinning blades of the ceiling fan. It is creating a rotational flow pattern within a room or within above the room. An example of a non-rotational flow is when I pour the water inside this bottle into this mug. But why? It is because the fluid moves from one place to another place without any rotation. This type of flow is called laminar flow, which represent a non-rotational flow. In my one-dimensional flow of fluid, two-dimensional flow of fluid, three-dimensional flow of fluid, I'll be giving you the example at our boarding house. So let's go. Hello, and we're back, and now I am here in our Hades boarding house. So I'll be giving you the examples that I've said a while ago about the one-dimensional flow of fluid, two-dimensional flow of fluid, and a three-dimensional flow of fluid. So let's go. An example of one-dimensional flow is when I blow air through this straw. It is because when I blow air through the straw, the air moves in a straight line through the length of the straw, exhibiting one-dimensional characteristic. An example of two-dimensional flow is when I open this faucet, letting the water falls down on a flat surface. The flat surface, water, the faucet. But why? When a drop of water falls from a faucet, it moves in two dimensions. The first one is the vertically downward due to gravity, while the second one is horizontally as it travels through the air or along the surface or the flat surface. This is the flat surface, which is exhibiting a two-dimensional flow characteristics. An example of three-dimensional flow is blowing an air through this balloon. But why? It is because as the balloon inflates, the air fills the entire three-dimensional space inside this balloon, demonstrating three-dimensional flow characteristics. And that's all the examples that I've noticed in our campus and here in my boarding house that relates in the type of fluid flows. And I hope you like my video documentation of the examples. Thank you and goodbye.